Web applications have become a mainstay of the software development world, so frameworks that allow you to create them more quickly, easily, and consistently are more important than ever. ASP.NET MVC5 not only provides the framework, but also the world-class tooling that comes with Visual Studio, which you need to build amazing web applications. MVC5's patterns and conventions also help developers organize their code, allowing them to focus all of their attention on the unique business problems that they're trying to solve. Hi, I invite you to join me for this introductory course on LinkedIn Learning, where I'll show you the essentials of how to leverage the ASP.NET MVC5 framework to build powerful web applications. To get the most out of this course, it will be helpful to understand a few basic prerequisites. First, I'll assume that you already know C# and .NET, as well as some of the basics of HTML and CSS, and that this background knowledge is one of the reasons that you're interested in learning about building web applications using MVC5. If that doesn't describe you just yet, I recommend you start your learning with Become a C# Developer, which is a learning path in our library to help you learn C# and .NET, or that you start with the course HTML Essential Training to learn the basics of HTML and CSS. After that, you can come back here and continue with ASP.NET MVC5. Second, I'll be using a little bit of Entity Framework 6 as an ORM, or Object Relational Mapper, and so I'll assume you already have some basic understanding of how Entity Framework, or ORMs in general, work to help you read and write your data to and from the database. You don't need to be an expert in EF at all, but understanding it a little will help you with some of the examples later on, making them a little bit more meaningful. If you need more on Entity Framework 6, a good course to start with would be the Learning Entity Framework 6.1.3 course, right here in our library. If you already understand all of these prerequisite topics, you will be in an ideal position to get the most possible out of all of this course. Throughout this course, we'll be building a real ASP.NET MVC5 application. To do that, we'll be using several very common tools that .NET developers use to build lots of different kinds of .NET projects, including their ASP.NET MVC5 projects. Probably the most common .NET development tool, and also the primary one we'll be using in this course, is Visual Studio. We'll use the 2019 version of Visual Studio, which is the most recent version at the time of this recording. I'll be using the Enterprise Edition, but there's also a Professional Edition and a free Community Edition that would both work for anything that we're doing in this course. Use the link shown to download the free Community Edition of Visual Studio 2019 if you don't already have another edition installed. The next tool we'll be using is SQL Server. This is a Relational Database Management System, or RDBMS. We'll use this as the persistence layer for our sample application. But there's no need to install the full version of SQL Server on your development computer. Visual Studio actually comes with a development version of SQL Server called SQL Express Local DB that you can use for anything in this course and for most development purposes in general. To ensure that you have SQL Express Local DB installed, open the Visual Studio installer and click on the Modify button next to the version of Visual Studio that you have installed or that you are installing. If you click on the Individual Components tab and scroll down toward the end of the Cloud, Database, and Server section, you'll see the option labeled SQL Server Express. With those tools installed and set up, you'll have everything that you need to be able to build ASP.NET MVC5 applications. This course comes with exercise files that, throughout the course, we'll be adding to and changing in order to create a real ASP.NET MVC5 application. The project we'll create is for the H+ Sport brand, a fictitious sports equipment and supplement brand. We'll imagine that the H+ team has hired us to help them create a new e-commerce site where they can sell their products online, and we've selected ASP.NET MVC5 for the project. Once you download the exercise files for any video, you can unzip that file and open it up. After you do so, you'll see two folders, Begin and End. The first is the starting point, and the second is the ending point for that video. Beneath each of these, there may be a data folder and a code folder. The code folder will contain the code files for the project, and later in the course, the data folder will contain a .bak file, which is a SQL Server database backup file that you can use to create your own database. As I mentioned, the code in the begin folder is the starting point for the exercise files in the current video. I recommend downloading the code for each video if you plan to work along, because sometimes I'll be adding some additional code files to the project for you in the begin folder that weren't there at the end of the previous video. This is done in an attempt to save you some time with things that aren't central to the topic of this course. I'll call that out whenever I do it. Once we've completed all the work in a given video, your version of the project should look a lot like the version that I created in the end folder of the exercise file. If you get stuck with anything along the way, you can always pause and look at the solution in the end folder to see how I did it and how that fits into the context of the entire application. Now that you know more about the project we'll be building, let's get started building our ASP.NET MVC5 application. The Model View Controller pattern is a very useful design pattern that ASP.NET MVC follows and actually was named for. At the time it was introduced, ASP.NET consisted mostly of something called web forms applications. So the MVC moniker was tagged onto the ASP.NET name to differentiate it from web forms. When I first learned MVC, I had been doing web forms development for many years, and the way that MVC instantly encouraged easy, clean code felt like a breath of fresh air. I'd like to do a quick overview of the MVC pattern to make sure we're all on the same page. If you're already very familiar with this pattern, it might make sense to skip to the next chapter. For those less familiar with it, MVC is an acronym which stands for Model View Controller. The first and central part of the MVC pattern is the model. Models are objects that represent the data or the internal state of the application. They're also meant to contain the majority of the application's logic, though this is not always strictly the case. Views are the part of the MVC pattern that the user sees and interacts with. In a mobile or desktop application, these might be built with a presentation framework such as WinForms or WPF. The view receives user interactions and input and passes those on to the model. The controller is like the traffic cop in an MVC application. It handles a request and routes it to the correct view and model. In an ASP.NET MVC application, your controller code is usually the first code to execute for each web request. Looking at this diagram, you can see how these components, the model, view, and controller, fit together. Starting at the bottom of this diagram where the user triggers a controller, you can see that the controller creates, loads, or otherwise manipulates a model object to represent the application state changes that the user requested. Then, the model class is given to the view, where it's bound to the view or otherwise changes the view, causing it to be updated. Finally, the view is presented to the user, where they can choose to interact with the application again, restarting this cycle. Let's go through this diagram with a specific example. Imagine a user is on a view listing several products, and that user wants to view the details of one of those products. That user might click a linked product name, which triggers the product controller. That controller will use the product ID from that link to load a model, perhaps a product record from the database. That model will then be bound to the product detail view, which will be sent back to the user to view and interact with again. Using a pattern like MVC has many advantages which actually make you a better developer, make your application easier to maintain and create, and help teams work together more efficiently. Separation of concerns is the practice of breaking your code into distinct responsibilities or concerns that overlap in functionality as little as possible. For example, in MVC, that means that the view doesn't care where the model comes from or how it works. Its only concern is how to properly display that model to the user. The controller, on the other hand, knows how to load the model from the database and how to route a request to the correct view, but nothing else. Each piece handles its own thing. Because the MVC pattern is so well organized, MVC applications tend to be easier to maintain. Thanks to separation of concerns, we don't have to worry about display logic and application logic being mixed together in the code. And also, we can quickly and easily find where existing code is located to update it because the pattern is so prescriptive about where things should go. For example, your user authentication code isn't likely to get mixed up with your order processing code, since they're likely to be in very different places, models and controllers, to satisfy the requirements of the MVC pattern. By separating our concerns, we also allow ourselves more easily to reuse code in our application. For example, if two different screens in the application display an order model, we can use that same order model in both views without having to worry about that code being duplicated business logic throughout our application. The MVC pattern also encourages two important things to a software engineer: low coupling and high cohesion. Low coupling means that the code in different areas is independent of the code in other areas, and high cohesion means that related code can be placed together. This is something that happens very naturally when you follow the MVC pattern. Finally, the MVC pattern allows teams to work together more efficiently. Source control systems such as Git allow developers to work on code files at the same time and to merge those changes together later. But by separating code into different features and different areas of concern, MVC allows teams to work in different areas of the application without the need to make changes to the same files quite as often. ASP.NET MVC implements the MVC pattern and therefore brings all of those advantages to the table. In addition, it has some of its own framework-specific advantages. For example, unlike some HTML generation frameworks, ASP.NET MVC gives you full control over the exact HTML that it generates, allowing for very fine control over the rendering of your application. The naming and folder organization convention of ASP.NET MVC also help keep your application organized and enforce the separation of concerns. By keeping your logic separate from the presentation, MVC makes it easy for you to create unit tests for your application without worrying about the specifics of the user interface. It was also built to embrace the stateless nature of the web and the HTTP protocol. This makes it easy to avoid making bad architectural decisions that are possible in other frameworks which try to hide the stateless nature of the web from you. Finally, ASP.NET MVC allows you to create more human-readable URLs that aren't dictated to you by the way that you've organized your code files. These URLs also allow for better search engine optimization, or SEO, for your application. Let's use Visual Studio to create a new MVC5 project and look through the pieces that it sets up for us. You'll notice that Visual Studio 2019 opens with this start screen. This dialog includes a list of recent projects, plus some buttons along the right-hand side to clone a repo, open an existing project, open a folder-based project, or to create a new one. If we click this last button to create a new one, it takes us to the New Project dialog. Now we're presented with a list of project starter templates, including any recent ones we might have used listed along the left-hand side. On the right, we can search all of the different installed templates or filter them by language, platform, or project type. Since we're building an ASP.NET project on C# and ASP.NET only supports Windows, at least before ASP.NET Core, that is, so let's go ahead and filter it by the language C#, the platform Windows, and the project type Web. Notice that the second one listed is an ASP.NET Web application based on the .NET framework. That's the template that we're going to want to use to create a new ASP.NET MVC5 project. On the next step, we can name our project, give it a file location, pick a target template framework version. I'll accept all of the defaults here except for the name, which I'm going to change to h+.ecommerce. And then I'll click Create. Within the ASP.NET project template, there are some additional options I can choose from. So before I can actually create the project, I have to select a sub-template. If I choose Empty, it'll create an ASP.NET project with a very minimal set of features included. Choosing Web Forms creates the Web Forms type of project with its unique programming model. Skipping ahead, I can also create an API project or even a single-page application project with ASP.NET and JavaScript, but I'm going to select the middle option, which is for MVC. I could select some additional features to be added along the right-hand side, but for this example, I'm going to leave the default options as they are. And now I'll click Create. Now Visual Studio actually creates the project files for me, including adding all of the required references and NuGet packages needed to run it. When it finishes doing that work, I can see over here in the Solution Explorer that it has also set up a basic starter project for me with some of the basic configuration already in place and some sample code files added to it. Next, let's review these files to understand what each one is and how it works. Let's review the items created for us by the project template by looking through them in Visual Studio's Solution Explorer. First, you'll notice we have an empty app data folder. This folder can be used for file-based databases or other data files, but it's empty in this template. Next, you'll notice the app start folder. It has a few C# code files in it, which configure the application at startup. I'll delve more deeply into each of these in the next video. Next, we have the content folder, which contains static content files, primarily CSS files for the Bootstrap front-end framework, but also one application-specific CSS file called site.css. This template project includes a single controller class called homeController. If we look inside of that class, you can see that it has 3 different methods: index, about, and contact. Notice that each one of these returns its results using a view helper method. We can run this application and you'll see that each of these methods maps to a page in the application. And later in this chapter, we'll see just how that connection is made. Moving on, notice there's a fonts folder with the web fonts that are used by the application's CSS. These are also static content files, so if we wanted to consolidate these with the CSS files, we could do that if that made sense. Next is the models folder. Here's where we'll put all of our model classes, which are the M in the MVC acronym. Later in this course, we'll review using model classes, and when we do, we'll add these classes right here. Note that your model classes don't have to be in the models folder. It's just a convenient way to organize your files and a convention for ASP.NET MVC5 projects. Next, we have the scripts folder, which is more static content files for the site. This time, though, it's JavaScript files, which are used by the site, mostly Bootstrap and jQuery. Again, these don't have to go in a script folder specifically, so if we wanted to consolidate these with the CSS and fonts, we could certainly do that. One final folder in the project is the Views folder. This is the V in the MVC acronym. Directly under it, you'll notice a couple of files, including a web config file. If this site is hosted in IIS, this web config file has a special handler called block view handler that blocks access to view files so that your views can't be downloaded directly, possibly exposing any secrets in your code to the end user. There's also a viewStart.cshtml file. All CSHTML files are views that use something called razor syntax, which is something we'll be going into a lot more detail on in this course. The view start in the top level folder like this is a place where you can set default settings for all of the views. You'll notice that this one sets just one property, the layout property, which we'll talk about more very soon. This setting applies to all of the views in the application unless they override it specifically. Now let's look at the 2 folders inside the Views folder, the Home and Shared folders. You may have noticed that the Home folder name matches the name of the one controller class that we have in this project, the Home controller. By convention, all of the views for the Home controller will be under this Views/Home folder. You can override that, but if you're following the ASP.NET MVC conventions, this is how it will be set up by default. The Shared folder is a place where you can create views that are used by multiple controllers or views. You can think of this as sort of like a shared or global views available throughout your application. The most common use for these is something called a layout, which is a reusable page template, but we'll talk more about that coming up as well. Now we're down to the last few files in the project template. The first is a favicon.ico, which is that little icon that appears in the browser's address bar or bookmarks for your site. The Global.asax file is where you can handle application-level events. Packages.config is a list of all the NuGet packages in this project, and the web config file has all of your ASP.NET configuration settings, your own configuration settings, like connection strings, and potentially any IIS configuration settings as well. Before getting too deep into ASP.NET MVC, it can be helpful to understand how it handles incoming HTTP requests and creates the outgoing HTTP responses. The ASP.NET MVC5 framework follows a very specific pattern for this request and response cycle, allowing you multiple different places along that path to intervene with your own code, but only one place where you have to. Each web request starts with a user making an HTTP request, usually a GET or a POST, though there are several less common options. ASP.NET uses routing tables, which are defined at startup and are primarily based on the file and folder path in the web request. These routes are used to figure out which controller class to route the request to. Once the correct controller is identified, a new instance of that controller class is instantiated and initialized. Once that controller instance has been created, the appropriate action method in that class can be executed. Now your program code is actually being run, specifically your code in the controller class in question. The results of the action method is an object that inherits from the ActionResult base class. This object is what is executed on the next step. Sometimes this action result represents a simple HTTP response with just a response code and no body. Other times it can be a JSON formatted string. But in MVC applications, the most common response is a view built with Razor syntax and bound to a model class. If that result is a Razor view, the view engine is used during the result execution to turn that Razor into HTML that can be displayed by the browser. Either way, though, the result ends with some valid HTTP response being sent over the wire to the user. Usually that means a Razor view inside of a 200 OK response with the HTML being sent inside the body of that response. The HTTP response is sent back to the user's browser where it downloads and displays this page of the application in its new state, and the user is now free to interact with the application again to start a new request and response cycle. I mentioned that there are several places during this lifecycle when our code can run. The most common place for that is during the action execution, when the controller's action method code actually executes, and when your Razor code is executed and the Razor view returned by the action method. You can intercept the result or response in other places, though, with something called filters. We'll cover these in more detail later in the course, but in general, you can intercept the request first for the purpose of authorizing previous authenticated users, then for authenticating users that haven't yet been authenticated, then a general purpose filter you can apply to an action or many actions, and another one that applies right after an action has executed. Next, you can filter results before they are turned into an HTTP response. And finally, you can globally handle exceptions for the entire application. When we looked through the template project's files earlier, I glossed over a couple of areas, the Global.asax file and the contents of the app start folder. I'd like to go into some more detail on at least one line in the Global.asax file now, and delve more deeply into how the requests are routed in an ASP.NET MVC5 application. When we look at the Global.asax file in Solution Explorer, notice that it actually opens a file called Global.asax.cs. This is called a code behind file, and this is a pattern that's a holdover from an earlier version of ASP.NET. The reasons for this are outside the scope of this course, but I just wanted to point it out to help avoid any possible confusion for you later. Inside this class, the template project has created a single method called applicationStart. We'll cover this method more later, but right now, I just want to point out that this method fires when the application first starts up. The one line I'd really like to focus on is line 17, the one that calls the route config. The route config class is code that is defined in our project and was created for us by the new project template. If we go to the app start folder and open the routeconfig.cs file, we can see where the route config class is defined. Routes in MVC are a set of rules that the framework uses to map a URL requested by a browser into a specific controller and action method that will handle that request. They're implemented as a routing table, which is a list of patterns matched in a specific order from top to bottom, and the pattern that matches any given request first is the one that is used to select the controller and action method that will be used to handle that request. Routing rules can also match pieces from the URL path into route parameters such as the controller name, the action name, and an ID parameter that can appear in the default route here. Each of these is identified with curly braces that surround them. They match either the controller name, action name, or that optional ID parameter, which is passed to the action method. Back in our project, you can see that there's only one rule defined for this project. The rule is named the default rule, and it's implemented in a generic enough way that this one rule could be used for the whole application as long as every controller follows this simple naming convention. Notice the curly braces around parts of the path. These are the route parameters, and their defaults are specified below. For controller, the default is home. For action, it's index. And for ID, it is completely optional in this routing rule. With only this routing rule, all of the following URLs would match the index action method on a controller named homeController. Or we could omit the index, since that is the default for the action. We can also omit the home and just go to the / directory on the base of the site, and that'll also match the home controller. Similarly, if we created a new controller called widget controller and gave it both an action method and a view named index, then the same single routing rule would also match all of these URLs, routing them to our new controller and action method. But notice that this time we can't match a route without a controller name specified, since our one and only rule says that the home controller is the default one, and in this case we're trying to route to the widget controller. Now let's finish looking at the Global.asax file and its application start method in some more detail. Besides application start event, there are many other application level and session level events that we can choose to handle in this file. Here's a complete list of the events. Notice that you can handle the beginning and ending of an HTTP request, new sessions starting and ending, authorization and authentication events, and many more. To handle one of these events, you simply add a method with one of these names to the global.asax.cs file, and as long as the name matches the event, the method will be fired automatically. I won't elaborate much more on these in this course, because it's actually pretty rare to need to use most of these, but I did want to make you aware that they existed. For this course, we'll primarily be interested in the application start event, because this is the event where we can configure our application when the application is first starting up. Now let's go back to the code and look at the other 3 lines of code in the global.asax.cs file and their corresponding files in the app start folder. We've already seen the routing configuration, so let's look at everything else that is being configured at startup besides that. In order, the first thing we see is something called areas being registered. I won't talk a lot about these in this course, but at a high level, areas are another way to organize related functionality in an MVC5 application into groups for routing and file organization purposes. The register all areas method is a static method defined on the area registration type that actually looks through our project for areas and registers them for us automatically. If you're not using areas, then you can remove this line completely. The next line is formatted in a very similar way, but is actually running code that's defined in this project by a file located in the app start folder. If we navigate to that file, it's called filterconfig.cs. You can see it simply adds filters that we want added globally to all controller actions on our project. We'll look more at filters, as I mentioned, later in this course. But for this project, you can see that the only global filter is one called the handle error filter, which handles any unhandled exception that bubbles up to this point. Going back to the application start method, our next line calls route config, which is the one that we've already looked at in some detail, so I'll skip that. Finally, there's a line of code that is registering something called bundles. We can see this code defined in the bundleconfig.cs class located in app start. Bundles are a way to combine static resources such as JavaScript and CSS files into a single download for performance reasons. There are both script and style bundles, and when you define either, you give it a path that it will respond to, like /bundles/jQuery in this case. Then you tell ASP.NET MVC what files to include in that bundle. In this case, we're looking for all of the JS files under the scripts folder that begin with jQuery- followed by some version number. All of our script and style bundles are defined in a similar way and allow us to have a more speedy download of those files and therefore a much more speedy web application. Now you should understand all of the code that is in the app start folder and in the Global.asax file, and what each line is doing there. Now let's use what we've learned so far about ASP.NET MVC 5 to create a new controller with a simple response. I'll go to the Controllers folder in Solution Explorer and right-click on it, then select Add Controller. In the dialog, I'll pick MVC5 controller empty and click Add. And I'll give it the name Hello Controller. Visual Studio now creates a simple controller class for us with the name Hello Controller. Notice that it returns the results using the view helper method defined in the controller base class. This will automatically look for a view in the views/hello folder with the name index.cshtml. So let's go create that view over here in Solution Explorer. I'll go to Views, and notice that the controller wizard has already helped me out by creating a hello folder. So I'll right-click on that folder and select Add MVC5 View Page Razor, which I'm going to name Index. I'm going to get rid of all of this code that it generated, and I'm going to replace it with an h2 tag with the contents hello. Now let's run this project and see what happens. I'll click on this play button up here, which will start my debugger and open up Chrome to my local development site. Notice that in Chrome, we're automatically navigated to /hello/index, which is displaying our hello message within the site's default layout header and footer. If we change the URL to just /hello without the index at the end, we can see the same page because index was our default action. We've now successfully created a controller and gotten a simple response from it using ASP.NET MVC 5. As we've seen, controller classes and their action methods are the primary entry point into your code whenever a web request comes into your MVC application. Let's jump in and find out more how these controller classes and their action methods are used to organize your application's logic. An action method is just any public method that we define on a controller class. These methods usually map one-to-one with the user interactions in our application, such as viewing a page, clicking a link, clicking a button, or posting a form to the server for processing. As we talked about earlier, action methods can return anything that inherits from a class called action result. As you can see here in the hello controller that we just created, the return type that is being used for our index method is the action result class itself. If I control-click on that to go to the definition, we can see that this class is an abstract class in the system.web.mvc namespace. The ASP.NET team defined this class for us, but because it's abstract, we can't actually instantiate one of these in an action method. Instead, this class has to be inherited by a derived class. Any method that returns a class inheriting from action result will work just fine as an action method in MVC 5. Going back to the home controller, if I control-click on the view method and scroll up a little bit to the top of this document, you can see that it is also defined in the system.web.mvc namespace inside of the controller base class. Notice that all of the different overloads of the view method return a view result, not an action result. If we dig down one more level by control-clicking on the view result, we can see another class defined in the System Web MVC namespace. This one is called viewResult, and it inherits from viewResultBase. One more control-click on the viewResultBase, and we finally see that it inherits from actionResult. In other words, we can treat a view result in our code as an action result because of their inheritance relationship. Or, to use object-oriented terms, there's a polymorphic relationship between action results and view results. Now let's start building that e-commerce site for the H+ Sports brand. We'll start by setting up a new view to return from a new action method on a new controller. Before we do that, though, I want to point out that I made a few changes to the exercise files. If we run the application right now, notice that I updated the ASP.NET MVC template or layout, and it looks a little bit more like a real site for H+ Sports. Most importantly, notice that there's a new navigation menu item called Our Products. If we click on it, we actually get an error message right now because that page still needs to be created. To create the page, let's go to Visual Studio, where I'm going to right-click on the controller folder and pick Add Controller. When I'm prompted, I'm going to select the empty MVC5 controller, and I'm going to name it Product Controller. Notice that Visual Studio not only creates the controller with its default index action method here, but if we also look into the Views folder, it has once again created a default folder for us for our views. It's currently empty, so let's create the new view in there. I'm going to name it Index to match the action method name. Remember that when we set up our routing rule, we set index as the default action if none was specified. So that's a good thing to use here. I'll select Add New View. I'm going to select the empty template. I'm going to name the view Index. And down here in the layout, I'm going to use the layout that is under Views, Shared, and then is called _layout.cshtml. That is in fact the view that I updated. Visual Studio now created a simple view for us. We'll look more into the details of this coming up, but for now, I'm just going to remove the contents of this view and replace it with something that I have added to this folder for you automatically. If you look at the exercise files and go to the Before folder, under the h+.ecommerce folder, there should be a file called productdetailhtml.txt. I've got that file opened up in Notepad, and I'm going to copy the contents out and place it right here at the end of this file. And then if I scroll back up, I will just remove a couple of blank lines, and there we go. Notice that I left the first few lines in place, That is everything between the curly braces. If we run this application now, notice that Chrome opens to the correct path for this view that we were just working on, which is /product/index. This is that cool feature of the Visual Studio debugger, which is aware of the naming conventions in an MVC project and does that for us automatically. Here we are now looking at our new product view that I built for you. Back in our controller class, I'd like to look at one other overload of this view method. Notice that the view method we're using right now takes no parameters. But if I mouse over, you can see there are 7 other overloads, or 8 total overloads of this view method in the controller base class. The one I'd like to zero in on right now is the one that takes one string parameter called viewName. This viewName parameter allows us to use a different view file from the default one, which is located in the views/product folder, and which matches the name of this action method, index. Let's say we wanted to name the file list.cshtml, but still use it as the result of the index action. If I come here and rename this to list, I can now go back to the product controller and specify list. If we run this again and click on our products, you can see that products, or product/index, both still result in showing that list view. Similarly, I could actually specify the full path to the file I would like to use. So for example, I could do tilde/views/product/list.cshtml, and this will also select the correct view for the index action. Once again, if I click on products, you can see that MVC5 is selecting the correct view. Often, the best response for a web request is a new or updated version of a view. But sometimes you want to send other types of responses. This is a list of all of the action result types or responses that exist in MVC5, including the view result type that we've already looked at extensively. Occasionally, you might want to return no result at all from your action. In that case, the empty result is perfect for you. Honestly, this hasn't come up very much for me, but I did want to mention it in the spirit of completeness. A much more common response is a redirect. A redirect tells the browser to send the user to a different URL. There are actually several different ways to do this in MVC5, including 6 different overloads of the redirect helper method. We'll look at one of those in just a minute. The JSON result class allows you to return JSON, or JavaScript object notation, formatted data. If you have JavaScript calling back to your server for more data, it can be very helpful to use this. Normally, if you're trying to return only JSON data from ASP.NET, you might want to use a Web API 2.2 application instead of MVC5. But this JSON result allows you to return JSON data from an MVC project without having to go that far. Sometimes you want to return JavaScript code to the front end and wrap access to that JavaScript with an MVC controller. This JavaScript result class allows you to do just that. The content result type is a nice catch-all for just about anything else you might want to send back to the browser. It allows you to set the body of the response, as well as the content type, to just about anything you can think of. When you'd like the user to be able to download a file, you can use one of the file results. Depending on where you're getting that file from, you could either use the file content result, file path result, or file stream result. Any of these types can be accessed by one of the many overloads of the file helper method that is available in the base controller class. Now I'd like to look at a simple example of doing a redirect. Let's imagine that our new e-commerce site is replacing an old site. Perhaps that old site had a product list at the path /products with an S at the end, instead of just /product singular, like we have it now in our new MVC5 application. We can easily handle that situation by creating a new controller called the products controller with an S. I'll do that now by right-clicking here and picking Add New Controller. I'll create an empty one, and I will call it Products Controller with an S. In this controller, let's replace the view method with a redirect to action. This method allows us to select an action of another controller to redirect to, and based on our routing rules, it will generate the URL for us automatically. I'm going to specify the index action of the product singular controller. So this should redirect the user from /products to /product, which is our new product list page. Let's start the debugger and test it. In the browser, let's type the path /products with an S, and notice that we automatically are redirected to /product. So the redirect result created by our call to the redirect to action method is working perfectly. We've already looked at routing requests to our controllers and action methods in MVC5 using the conventions-based routing table. This can cover a lot of routing scenarios, especially if you follow the naming convention closely. However, sometimes the routing rules in a larger application can get increasingly complicated. When they do, they can accidentally conflict with each other, causing errors or other unexpected results. Additionally, they can be hard to manage because they're in the route config class, so far removed from the controllers and action methods that they're actually routing to. To solve this problem, MVC5 allows you to route to your controllers and action methods using something called attribute routing. In .NET, attributes are those metaprogramming commands that you put in square brackets before a method, property, or class definition to change how it behaves. Attribute routing simply uses .NET attributes to route requests to your controller's action methods instead of using the routing table. To add attribute routing to our H+ Sports project, we'll go to the route config CS file under the app start folder, and we'll add the command routes.map MVC attribute routes. And that's all it takes. If we want to just do exclusively attribute routing in our project, we can simply remove this routes.maproute command right here, and our project will only use attribute routing. But if we leave both commands in, then this project will use both the routing table and attribute routing together. The most basic attribute used in attribute routing is the route attribute. It allows you to specify the URL path that you'd like to use for this action method. In the second example shown, the route is being changed to product/list. Note that all of the routes are assumed to start from the root of the website so that we don't need to use the leading slash. When you're using the routing table routes in MVC5, the controller names automatically prefix all of the routes in that controller. With attribute routing, you can use the route prefix attribute in front of your controller class to do the exact same thing. In this example, all of the action methods in this controller will start with /product, followed by a slash and then the specific action method route. If you have a route prefix and want to override that on a specific action method, you can do so by defining your route path beginning with a tilde character. Then, the route prefix will not be added to the front of the route's path, but it will start at the root of the site. Finally, I'd like to point out that you can also use the route attribute at the controller level. This example route specifies a default action name that is going to be used for all of the action methods in this controller, and that action is index. Unless a specific route attribute is applied to an action method that overrides that default name of index, then index will be used for the action. One really nice feature of attribute routing is the ability to create custom parameters for a single route. Instead of just using the default route's optional ID parameter, we can now create any parameter we want, even if it's just for a single use. These parameters are defined inline in the route path using curly braces around them. For example, you could use a username in the path to display a user's profile picture, like in this example. Notice the username parameter is in curly braces in the route, and that exactly matches the name of the username parameter in the action method. MVC5 will match that part of the URL and pass it into the username parameter of this action method, allowing you to then retrieve the correct user profile picture from the database. Let's add a new action method to our product controller called detail. This will route our users to the product detail page for a specific product. For readability and for search engine optimization, we'll use the product name in the URL path. Let's accomplish this by adding a route attribute. And for the path, we'll use product / and then product name in curly braces because that is going to be our parameter. Then we'll add a string parameter to the action method, also called product name. And we could use that right here to look up the product name in the database. And then use that product to pass to the view to return a view to the user. If you want to limit the values that a parameter will match, you can use something called constraints. There are several built into MVC5, but you can also define your own custom ones if you want. Displayed here is a list of all of the built-in constraints. As you can see, there's many different ones that can help you limit the type of a parameter or the format of the data. There's even a regular expression, or regex, constraint for matching complex patterns. The format that you use when you're adding a constraint to a route parameter is the route parameter name followed by a colon followed by the constraint name. For example, in this code, it looks for only paths that begin with user / and then a user ID, which has to be in the form of an integer value. If you'd like to indicate that a parameter is optional, you can simply use a question mark after its name or after the constraint name that you've applied to it. You'll also want to make sure that the matching parameter on your action method allows either an empty or null value. For example, in this case, I've changed the integer to a nullable integer, and I've defaulted it to a null value. If you'd like to make your own custom constraint, you can do that simply by creating a class that implements the iRouteConstraint interface. To implement the interface, your class will have to have a match method. The match method gets all of the data passed into it about the route, the web request, the user, and so on. It returns a true or a false depending on whether or not the route should match. Once you've created your custom constraint, then you actually need to register it for the application to be able to use it. You can probably best do this in the routeconfig.cs file. You can do this by getting the constraint resolver, here called the default inline constraint resolver, and then adding your constraint with the string key value that you want to use to identify it. Then, throughout your application, you can use that string value after a colon for any parameters that you want to apply that constraint to. Let's create a way for users to log in with their existing H+Sport account if they already have one. We'll start by creating a new MVC5 controller called Login Controller. I'll create it as an empty MVC5 one and call it Login. Notice that Visual Studio created an index action for us. So let's go create the view for this Login Controller's index action. We'll do that under Views, Login, and we'll say Add a View. The view will be called Index. We'll use the empty template, and for the layout page, I'm going to use a _layout.cshtml file defined here under Views Shared. and I'll click Add. Now in the exercise files for this chapter, I added a text file called login.txt where you can get some HTML that I wrote for you. I'm going to go ahead and copy that and paste it in instead of this h2 tag. Notice that there's some code that creates a form. We'll look at that more in an upcoming video. And then in that form, there's both a username and a password field, plus a label for each of those, and a submit button to submit the form. With that page created, let's create another page that we can secure access to using the login form. To do that, we'll create another new controller, also using the empty template. I'll call this one the account controller. Now we need to go create a new view for the account controller's index action. And we'll call this index. And we'll go ahead and use that same layout page we've been using. We don't need to add much here yet, so let's just put an h2 tag with the title, My Account. To secure access to this view, let's go back to the account controller, and we'll add an attribute we haven't seen before called authorize. The authorize attribute marks a class or an action method in a way that tells ASP.NET MVC5 to check for a valid user before allowing access to this action or to all of the actions in this controller. With that set up, let's go to the web config where we will configure something called forms authentication, which we're going to use to create our authentication cookie. We'll go to the system.web section and we'll add a new node called authentication. And we'll set its mode equal to forms. And then within there, we'll add a new node called forms, which allows us to further configure forms authentication. And we'll set the login URL to /login, and we'll set the default URL to just /. That tells forms authentication to redirect any unauthenticated user to /login, and after they log in, to redirect them back to the root of the site. That is, if they didn't come from some other page to begin with. Finally, let's add some simple C# code to create a valid login cookie when the login form is submitted. Here in the login controller, I'll go ahead and copy my index action and make a new action called index. But on this one, I'm going to add a couple of string parameters, one called username and one called password. Now these names match the exact names used on the HTML form, and that's going to allow MVC to map data from those form fields into these parameters for me automatically. I'll also add an attribute called HTTP post. This will tell ASP.NET MVC5 to route any post requests to this index route to this specific method. GET requests are the default, so since it's not specified on the other action method, the first index action method will receive any GET requests for this route. Inside my action method, I'll do a very simple bit of code. First, I'll just check to see if the username is not null or empty, and that the password is also not null or empty. And if that's the case, then I'm going to call a class called forms authentication, and I will tell it to set the auth cookie using the username that was given to us, and a false indicating that we do not want the cookie to be persistent. In other words, it will expire when the user closes their browser tab or window. And finally, we want to do a redirect here, so I'm going to do a return statement that does a redirect. And this takes a string URL. We can actually ask forms authentication to get the redirect URL. And we'll pass again the username and false to that. Now let's test what we built. I'll go ahead and start the Visual Studio debugger, which will open up Chrome. And if I try to navigate to the account path, you'll notice that it redirects me back to the login path. That is due to the authorize attribute that we added on the account controller. If I go ahead and enter something non-null or empty into each of these fields and submit this form, you can see I am now allowed to access the account view. The reason for this is that an authentication cookie was created, which allowed me to get past that authorize attribute on the account controller. Sometimes you want to execute the same code in multiple different action methods. In some cases, you could accomplish this by using object-oriented programming practices such as inheritance, but ASP.NET MVC provides another simple way to accomplish it using something called filters. Filters allow you to inject some extra logic into the request processing pipeline of an MVC5 application. They're often used to implement cross-cutting concerns such as filtering, logging, authorization, or caching. In the previous chapter, we looked at one of these types of filters, authentication filters. But there is actually 5 different types: authentication, authorization, action, result, and exception filters, all working in very similar ways, but with a slightly different purpose for each one. One of the major differences about each type of filter is when it runs in the request or response pipeline. The first filter type is called authentication filters, and these are responsible for verifying your identity via a cookie once you've already logged in. If you want to customize how this works, you can create your own authentication filter, and it will run very early in the request pipeline. The second type of filter to run is the authorization filter. We actually used one of these already to secure access to only logged-in users accessing the account page. These are typically concerned with whether or not a specific user has access to a specific route or action. They can be customized, of course, but for most scenarios, the built-in one should do what you need. The next one to run is the action filter. Like the name suggests, this actually runs with your action method, either right before or right after the action method executes. Because they both run after your MVC model is bound, they are the most useful and probably the most common ones that you'd want to create in a typical application. Any action filter you create can choose whether to execute during the onActionExecuting handler, which is run right before the action method, or during the onActionExecuted handler, which is after the action method. Or, of course, they could run in both. The fourth type to run is the results filter. These run after the action method finishes and after the returned view result is already rendered. These can be helpful if, for example, you'd like to parse the final HTML and make some changes to it before sending it off to the browser. We'll talk more about the rendering of views in an upcoming chapter. And the final type of filter is an exception filter, which runs last and only if an unhandled exception has bubbled up through the action method in your controller. This is meant to be sort of a fail-safe to handle any exceptions that make it this far without having been handled in some other way. Now that we understand them a little bit, let's create our own filter. Specifically, let's create an action filter that logs the actions as they're executing. We'll start by creating a new folder for filters, and we'll call it Filters. And then we'll add a class to it called LogRequestFilter. To make this an action filter, we'll need to inherit from the action filter attribute class. The action filter attribute class implements the IActionFilter interface. I'd like this action filter to run before the action method, so let's override the onActionExecuting method. Now I want to create a simple log object as a new dynamic object. And I'll set its controller property based off of the filter context .action descriptor, .controller descriptor, .controller name. So that'll give me the name of the controller that's executing. And then I'll set its action property also based on the filter context action descriptor, action name. I'll also put in an IP address here, which I can get from the filter context .http context .request .user host address. And finally, I will add a datetime property, which I can get from the filter context .http context .timestamp. That's enough for now. I'll use a library now called json.net to convert this to a JSON formatted string for readability. So we'll use the JSON convert class, and we'll bring in the newtonsoft.json namespace, and we'll use its serialize object method, and I will pass my log object onto that. And finally, let's use a debug.writeLine to write out this result of the serialization of this value, and I'll get rid of the base class's implementation. Now, before I can run this, I need to actually add this filter somewhere. I can do that by adding it either as an attribute to a single controller or action method, or I can add it globally in the filter config by adding it to the global filters. So let's go to the filter config class, and I will copy this line here, and I will add my log request filter type. Now I'm going to run this and open up the debug console in the background. So now you can see as I navigate around that I'm getting new entries logged into the debug console that include information such as the controller name, the action name, the IP address of the user, and the timestamp of the request. Not only can we trigger code that runs during an action using a filter, but we can also alter the request and response using those same filters. As an example of this, let's create a filter we can put on our site to protect against certain pages being crawled by search engine crawlers. We'll add a new class to our filters folder, and we will call it crawler filter. To make this an action method, we just need to inherit from the action filter attribute. And because we want this to run before the action method so that it can actually stop the request, we'll want to override the onActionExecuting method. In this method, let's check the filter context, HTTP context, .request, .browser, .crawler. This will return true if the client is a known web crawler that is indexing the web. If it is, we'll just want to return a 404 response. We can do that by creating a new HTTP not found result, and we can set this as the result of the filter context. Now, we could add this filter globally, but let's imagine we just wanted to protect certain controllers in this way. So, for example, I'll add this crawler filter attribute just to the home controller. Now let's go ahead and test this out by running the project in the debugger. Notice the home page still loads just fine in Chrome. However, let's open up the developer tools and we'll go to More Tools, Network Conditions. And here we can change the user agent to Googlebot. This simulates that this request from Chrome is actually coming from the Google web crawler. Now if I refresh the home page, you can see that we actually get a 404 not found error. If I change the page to the login page, you can see that this page still loads fine. That's because we only protected the home controller with our new crawler filter, Action Filter. So far, we've looked at a few different kinds of filters in detail. Exception filters are another one that I'd like to show you in a little bit of detail. They allow you to handle any exceptions that are unhandled from the code in your controllers. The project template we used already has a global exception filter in it, which is called Handle Error Attribute. You can see it here on line 10 of the filter config. To get this built-in exception filter fully functional, we'll need to do one more piece of configuration in the web config file. If we go into the system.web node and add a new node called Custom Errors with the mode set to on, this will tell the exception handler to redirect to the default error page when any exception occurs that's unhandled. We can test out this default exception handler if we throw a new exception from the home controller. So let's go into the home controller. In the index action, I will just create a new line and throw a new system.exception. And let's run the project to see what this does. As you can see, the debugger hits our exception when it's thrown, so I'll go ahead and continue that. And now the browser actually redirects us to the default error page. If we look under Views folder, under Shared, you can see that there's a file called error.cshtml. This is the page that was displayed to us by the default exception handler. But what if I wanted to handle exceptions differently? I can create my own custom exception handler by creating a new class in the Filters folder, which let's go ahead and do and call it Custom Exception Handler. This will need to inherit from filter attribute, and it will also need to implement the IException filter interface, which requires us to have a method called onException. Inside this method, let's first use the filter context to get an HTTP context and use the server.mapPath to map the path error/500.html. This 500.html file, by the way, is one that I've added for you in the exercise files. Next, we'll continue by creating a new file content result, and we'll give it some bytes, and we'll give it a text HTML content type. For those bytes, let's actually read those using the system.io.file.readAllBytes, and we'll read it from that path that we calculated earlier using the server map path. Next, we'll set the filter context result property to this file content result. And then finally, we need to tell MVC that the exception has been handled by setting the exception handled property to true. Now back in the filter config, let's take this custom exception handler and replace the handle error attribute with the custom exception handler that we just created. And now we can run the project. Once again, the debugger stops when it hits the exception. We'll continue. And you can see here in Chrome that our new custom error handler is working by displaying this 500.html content. And now that we've tested it, let's not forget to go ahead and remove this exception from our home controller. As we've seen already, routing in MVC5, especially routing using the routing table, follows certain naming conventions. These conventions can be reconfigured, but I find that it's usually an excellent default way to organize your code. One of those conventions is having all of the views in the Views folder at the root of the project. With this default convention, MVC5 will search for a view in a couple of different locations. First, it will look for either a CS.html or a VB.html file in a folder with the same name as the controller under the Views folder. Both CS.html and VB.html files are a format called Razor views, one written in C# and the other in VB.NET. We'll be talking more about these in just a minute. The second place MVC5 will search for your view is in the Shared folder underneath the Views folder, using just the action name, omitting anything about the controller name. Remember that the routing engine will use the controller and action names from the route by default, so /home or /home/index will both route to the home controller's index action method. You don't have to use a view with the name of the action method, though. You can specify a different view name in the view method that you return from your action method. For example, you could have an action method named otherActionName, which would normally look for a view file called otherActionName.cshtml. But if you specify a different name, like index in this case, as a parameter to the view method, it will instead use index.cshtml for the view. Similarly, you can route to a view just with a path and file name to the view file. That allows you to route to a very specific view file without using either the controller name or the action name to select the view at all. ASP.NET MVC5 provides a shared folder under the views for a few different special purposes. First, you can put your layouts, which are like page templates, in this folder, and you can use them in views from any controller. Second, the handle error attribute filter that we looked at earlier looks in this shared folder for a file named error.cshtml. This is the view that is used for any unhandled exceptions when they occur in the application. Finally, if you'd like to create a view that is shared by multiple different controllers, you can put that in here as well. Based on that search pattern, it will be found if that view name isn't found in the controller named folder. MVC5 also provides an _viewstart.cshtml or .vbhtml file. This file has code in it that will run before each view in the application is rendered. This is particularly useful for setting common settings that you want to set as a default for all of your views, like the layout page that they should use. But you can also set other common default values for your views here, and whenever those values are set again in a specific view file, that setting will override this global default. ASP.NET MVC5 includes a special syntax for creating views that's called Razor syntax. Its goals are simple: to allow you to use pure HTML markup, mix in server-side code as seamlessly as possible, and to make the transition between those two seamlessly. Razor syntax includes two different file formats, CS.html and VB.html. CS.html is a Razor syntax that uses C#, while VB.html uses VB.NET. Because C# is a much more popular language in general, I'll be using that in all of my Razor examples. But just know that there are equivalent syntaxes for VB.NET that just differ slightly. In CS.html Razor files, the @ sign is the special character used to signify the beginning of a chunk of inline code within your HTML. In this example, you can see an HTML div tag and a /div tag with the contents coming from a string property of the view model named error message. Notice that there's no special indicator to mark the end of the code block after the model.error message. Razor is very good at automatically detecting the end of your code and the beginning of your HTML markup without any need for you to mark it. One thing to note is that all strings displayed on the page are automatically HTML encoded by MVC5. So if your string includes some HTML tags, those will display as encoded HTML and not actual HTML tags getting added to the document. This helps prevent some common security exploits like SQL injection or cross-site scripting. If you do need to display a string as HTML and prevent MVC5 from encoding it, you can use the html.raw helper method. This will prevent the string from being encoded. Just make sure that you're doing something else to make sure that that HTML string is safe to display on your page, and that this doesn't become a security vulnerability for your application. You can also use all of the common C# code blocks in Razor, like loops and conditional statements. Here you can see an example of a for each loop that outputs HTML list items. Again, notice there's nothing we had to do to mark the end of the code on the for each line or the end of the code after display name and before the /li tag. These transitions back to HTML are detected automatically by Razor in most scenarios. We just have to use the @ sign when we want to start out some inline code. Below that, you can also see an if-else block with a very similar syntax, including the lack of any need to mark the end of the code statements. Just the beginnings are marked with the @ sign. You can also write uninterrupted code blocks in your Razor file using curly braces preceded by the @ sign. Now let's walk through the process of parsing an example of an implicit Razor expression so that you can understand better how this works. Because the @ sign is the token that indicates the change from HTML into your code, this process is triggered anytime an @ sign is encountered in a Razor file in your project. This example is slightly simplified, but you'll get the idea. First, the parser checks to see if the token after the @ sign is a valid code identifier in C#. In this case, imagine that products is an object we've created elsewhere in our code, so it is a valid C# identifier. Because it is, we'll advance a token and go back to step 1. The next token is an open square bracket. Obviously, this is not a valid token in our C# code, so we'll move back to step 2. The next rule is to see if the token is a parentheses or square bracket. It is, so we'll move to step 3. In step 3, the parser matches up the closing bracket that matches the opening bracket that we just found. Now we advance to the next token and go back to step 2. This time the period is our next token, but step 2 is looking for a parenthesis or a bracket. We didn't find one of those, so we'll go to step 5 next. Step 5 is looking for a period, which is in fact what we just found. So we'll accept the period as part of our code expression and advance to the next token and go back to step 1. Step 1 is looking at our product name property as the next token. This is a valid identifier in C#, so we'll advance a token and loop back to step 1 again. This time it finds the word costs, which is not a valid C# identifier. So the Razor parser will go to step 2. It's not any kind of a bracket, so it will continue to step 5. It's also not a period, so it will jump to step 6. And step 6 indicates that we found the end of this code expression. That shows you maybe a little bit of how the Razor parser works when it's looking through your code for any implicit code expressions. If the code you're writing doesn't parse correctly with these simple rules, don't worry. You can make your code expression explicit just by surrounding it with parentheses. In the first example here, you can see the same expression that we just looked at in our implicit code example, but after the @ sign, we've got the code surrounded by parentheses. This explicitly marks the start and end of our code expression. Similarly, see how the image tag's file name is being explicitly identified in the second example. If you run into issues with implicit razor expressions being parsed the way you expect, you can always change them to explicit expressions. Sometimes you want to write several lines of C# code or create a function inline in your razor page. Whenever you're going to write multiple lines of code that don't create any content into the HTML document, you can use a code block by using curly braces after the @ sign. In addition to the comment syntax built into HTML for client-side comments, Razor adds a comment syntax for server-side comments. The important difference between server-side comments and client-side comments is that while neither of them is actually rendered by the browser, the server-side comments are not even sent over the wire. So even viewing the page source doesn't reveal the contents of the comment. They only appear in your server-side code. This can be convenient when you have a comment for the reference of your developers that you don't want to be sent to the browser. It can also be handy when you're temporarily removing a large chunk of code from a page because it doesn't even get sent over the wire. Your server-side comments, therefore, reduce the size of the overall page in the browser. Now that we know the basics of how to create a Razor view, let's look at how to reuse one view for both a GET and a POST request. An example of when you'd want to do this would be anytime you have a form that can be submitted. For example, saving a record or logging into an application. In those cases, the original form may need to be redisplayed to the user if anything goes wrong. We're actually doing this already in the login controller. You'll recall that if the user doesn't validate, which in our simple example here just means that there's an empty username or password, then we return the original login view. Let's continue to use the same view, but change the view slightly when it's been reloaded after an invalid login attempt. We'll start by putting an @ sign and then an if block here inside the form. Inside the if, we'll check to see if the view bag has a property called failed that equals true. By the way, we'll talk more about the view bag and how that works shortly. If it is true, then we'll create a new div tag and we'll add some bootstrap classes to it called alert and alert danger. And we'll set the message to invalid login attempt. Now back in the form post in the controller, let's set the viewBag failed property to true right here before we return the view. This should cause the div with that message to be conditionally added to the page. Now if we run this and view it in Chrome, and we navigate to the login page, the first thing I want you to notice is that there is no message displayed on this page, because currently the failed property of the viewBag should be set to null. But if I submit this form with nothing in the fields, notice that the message now does display. So we were able to reuse the same view for both a GET and a POST action on the login form. There's actually a useful property on views that we could use in this situation instead of creating our own custom failed property and putting that in the viewBag. Back in the login index view here, let's change the viewBag failed equals true condition to just check whether IsPost is true. IsPost returns true only if the view is being loaded during a form post request, and false if it's not. In the case of our login form, we redirect successful login attempts, so the only time we're actually displaying this page on a post is if the login attempt has failed. If we run this again and navigate to the login view, let's submit it once again, and notice that our message displays correctly still. Initially, we're doing a GET request to get this page, and so the message doesn't show. However, when we do this post and the form is redisplayed to the user, now the IsPost is true, so the message shows. Once a request is routed to the correct controller, and that controller retrieves the correct data, the data has to be displayed on the view. MVC5 provides several different ways to do this. The first option is the view data property of the controller and view. It's a dictionary of objects, each keyed by a string, that you can set in the controller and then retrieve using the same string in the view code. The second option is called the view bag, and we've used this earlier. It's a natural evolution of the view data dictionary. Instead of being a dictionary of objects, though, it's a dynamic type, so you can write code to set or get a property of the view bag object without having to ever define that property ahead of time. These properties can be of any type. If a property of a given name has never been set before, then it will be null. Once it's been set, it will overwrite that null with the value that you set. Temp data is the third option and works exactly like the view data, but its values last for the current request and the next request, unlike view data and view bag, which only last for the current request cycle. This option is primarily to support remembering the state of the model during a client-side redirect event. Finally, ASP.NET MVC5 provides the ability to pass custom model classes to your view. We'll look at this in some more detail in an upcoming video, but for now, let's focus on these other three options. Comparing them side by side, you can see that the view data and view bag are very similar in purpose and in lifetime. The main difference between the two is the programming model they follow for letting you set and retrieve values from arbitrary settings at runtime. The difference between these two and temp data is primarily temp data's lifetime, which is for 2 request cycles, not just the current one. There are some pitfalls with temp data, whether you're using it in a web farm or just putting too much data into it. And for that reason, I usually recommend that you retrieve your model data again from the database after a redirect. Let's try these out ourselves in our H+ application. First, we'll create a model class called product and add some properties to it. I'm going to add a public decimal property called full price. I'm also going to add a public string property called name. And I'm going to add another decimal property. This one is going to be called current price. A public int property called %off. A public string property called image path. And another int property. This one we will call star rating. Now let's go over to our product controller and set a new property of the view bag called product to a new instance of this product model object that we just created. Normally, we'd probably look this up in the database, but for now, let's just use a hard-coded value for it. Let's set the name equal to women's winter jacket. And we'll set the full price equal to 20, and the current price equal to 16. That means the %off will be 20, and the image path we will set to /content /images /products /1.jpg. And finally, for the star rating, we will set it to 4. And now we need to use these values from the view bag's product property in our view. So if we open the detail.cshtml view in the product views folder, let's replace each of these properties with a razor expression. I'll replace this product name here with viewbag.product .name. And this current price will replace on line 37 with viewbag.product.currentPrice. And here's the full price on line 38. We can replace this with viewbag.product.fullPrice. And here is the image path, which we can replace with viewbag.product.imagePath on line 48. The star rating is a little more complicated. We'll want to replace these li tags with a dynamic number of li tags and then fill it in with a disable number of tags to add up to 5. So I've written this code here, which is 2 for loops. You'll see from the first one here that it goes from 1 up to the star rating number and creates that many stars. And then the second one goes from the star rating up to 5 if there's any left, and displays those as disabled stars. Now we can run this project and click on our products, and then on the product name to go to the detail page. We can see all of the data in this page is displayed from our model object, passed through that view bag, including the prices, the star rating, the product image, and the product name. We've already seen how view data and the view bag are ways that we can pass data from a controller to our view in MVC5. These approaches are ways of binding the model and the view together. But there are 2 problems with these approaches. The first is that the model's properties are either strings in the case of view data, or dynamic properties that aren't typed until runtime in the case of the view bag. And there's nothing that will tell us at compile time if we get one of these names wrong. Instead, any typo we might make will only manifest itself at runtime with a runtime error. The second problem is that everything is treated as an object, or in other words, we don't get any strong typing with the different properties of our model. The @model directive was introduced a couple versions before MVC5, and it allows strongly typed models. It's Microsoft's solution to these problems in Razor syntax. You strongly type a model in a Razor syntax simply by specifying the @model directive near the top of the Razor page with a type name after it. This is the type that MVC will use for your model throughout this Razor view. Now, anywhere you reference model with a capital M in your Razor view, it'll be treated as the model type that you specified, in this case, as a list of order. Let's update our login page to have a strongly typed model. The first step to do this is to create a new model, which we will call login. And now I want to add the properties of the login form to this model. So I'll add a string property called username, and I'll add another string property called password. And now with this model created, let's go back to the login Razor view and add this model there. Here in the view, I'll add a new line at the top that starts with @model, and then I will fully qualify a path to our new login model type by doing h+.ecommerce.models.login. On the input tag for the username, I can set the value to that model property, which would be model.username. But I want this to also handle if the model is null. So I'm going to go ahead and put in the null syntax. And if it is, it will just be a blank. I'm going to skip doing the same thing for the password field for security reasons. If the user fails to log in, I think I want my password field to be blank and not include the password that they had previously entered. The last change we need to make is in the login controller. I'll change these string parameters to instead be my login model type. Now I'll update the references to the various properties. And finally, I'll add the model as a property to the view request. This will pass the model values back to the view to be displayed when the login fails. Let's test this out in the debugger. I'll go to the login form, and I'll go ahead and enter a username, but let's leave the password blank for now so that the login fails. And as you can see, it displays the error message that we previously created, but it also displays the username that I typed in the username field. Previously, this field would have been blank after we submitted. So this is a nice little user experience improvement, which we enabled very easily with a strongly typed model. There was one thing that wasn't ideal about our code in that last example, which was the null handling we had to do for when the model was null and there was no username property. ASP.NET MVC 5 provides some helper methods called HTML helpers, which solve this problem as well as other similar problems. HTML helpers are simple C# methods that are used to create HTML components, and especially for creating HTML components that display values from our strongly typed model class. Let's replace some of our HTML with code that is more strongly typed and based on our model. One of the simplest HTML helpers is the label helper. I can generate an HTML tag for an HTML label using some server-side code, which I'm going to put right here after my label, html.label. And I can pass to it a string with the text that I would like to appear in my label, which I'm going to call email address. If I ran this, my label would still be missing the custom CSS class control label. To add custom HTML attributes, I can just pass in a new anonymous object to the label function, and if I want to specify the class attribute, I'll create a class property. There's a problem with this though. Class is actually a reserved word in C#, so I actually have to prefix it with an @, which escapes any reserved words in C#. Now I can set this to control label, which is the name of the class I want to use. And now this HTML helper will create the label, including my custom CSS class. Comparing this to my label on line 13, I'm only missing one thing, which is the for attribute, which creates the relationship between the label and the input control. To get that, I'll actually have to use a different HTML helper method. Instead of html.label, I'll use html.label4. html.label4 introduces a different, more powerful kind of HTML helper, one with a lambda expression for selecting a property of our strongly typed model. In this case, we'll pass a lambda expression to select the username property. Then we'll pass the label text of email address, and we'll still use this anonymous object to set the class to control label. Before we can see how label4 works, we also need to add an input field for the username property, but let's do that with a different HTML helper, which is called html.textbox4. For this HTML helper, I'll select the username property again using a lambda expression. Then I'll pass an anonymous object again with the class property, but this time I'll set it to form control. I'll also set the placeholder to email address, and I'll set the autofocus property to an empty string. Now let's comment out our old lines of hard-coded HTML And let's run this so that we can see the HTML that these HTML helpers generate for us. Here on the login form, let's see if I click off of the username field, and now you can see it no longer has focus. I can also click on the email address label, and you'll notice that it re-gives focus to the username field. That's because of the strongly typed relationship we made between the label and the username property, and then the text box and the username property. MVC5 automatically created a relationship between this label and text box for me in HTML. Not to mention, now my view code is strongly typed, so if I changed the name of one of my properties on my model, I'll get compiler errors to remind me to also change those property names here in the view. Besides the label and text box helpers we looked at, MVC5 includes built-in HTML helpers for lots of different HTML tags like forms and links, text areas, radio buttons and checkboxes, list boxes, password fields, and even hidden fields. Let's look at a couple examples of some more advanced uses of HTML helpers. First, I'd like to show you the action and action link HTML helpers. If you look at the layout that I created for you, notice that this link around the H+ logo on lines 22 through 24 has an anchor tag with an HTML attribute being set using the URL.action HTML helper. The URL.action HTML helper creates a link to an action method using the controller and action names. Just a few lines lower on line 28, notice the HTML helper called URL.actionLink is being used. In this case, this doesn't just generate the URL to an action, it also generates the entire link or anchor tag with an href set to the URL of that action method. You can see that we can also specify the text to use in the contents of the link. So here we're using our products. Another useful HTML helper that's built into HTML5 is the begin form HTML helper. Since a begin form also needs an end form, the begin form is implemented using the IDisposable interface in C#. If you're not familiar with it, any class that implements the IDisposable interface is one that can be used in a using block syntax in C#. The object is created at the beginning of the using block, available for use throughout the body of the block, and its dispose method is automatically called for you at the end of the using block. In the case of the begin form HTML helper, that means it has an opportunity to create the beginning of the form and the end of the form for you automatically. Let's replace our existing hard-coded form tag with an HTML helper created one. First, we'll create a new code block with the @ sign. And we'll start with a using block. And in the using block, we'll do HTML.begin form. We want the form to post to the index action of the login controller, so we'll make those the first two parameters. We also want it to submit with the return URL query string value. So I can do that by creating a dynamic type here and setting return URL equal to request.queryString return URL. That'll grab the return URL from the request and put it back into the query string. Next, we want to do a form post, so we'll do form method.post. And finally, we want to set our custom CSS class. So we'll do another dynamic type here and set the @class property to form-signin. And now let's put the body of this form into the new form using block. And notice here at the beginning, right after the using block, I have no HTML code between that and this if statement. So I no longer need this @ sign to switch to C# code. Now we can remove the old HTML form tags. And let's go ahead and test this out. I'll start by trying to go to a secured page, which you may recall the account page is. And you can see that I'm redirected to the login form with the return URL being set to the account page. If I log in by putting some values in both fields and hit enter, you'll notice that it still redirects me to the account page like it used to. So this new form is still submitting just like the old one did. But now we're using HTML helpers to generate it instead of just simple hard-coded HTML markup. Sometimes you want to be able to create a chunk of code that you can reuse in your Razor page in multiple places. One of the ways that ASP.NET MVC 5 allows you to do that is with something called inline HTML helpers. Let's look at some slightly repetitive code here in the layout page that I created for you. Notice this menu button on lines 17 through 21, which displays only on the mobile version of this page. And see how it has 3 of those spans with the icon bar class? If I run this so we can see it in Chrome right now, and make the window smaller so it'll load the mobile version of this, you can see in the top right corner here how it displays a menu with 3 lines. Those are the 3 spans in our code. Imagine we wanted to be able to create these with any number of those lines at different places in our code. It might be helpful to have an HTML helper method that we could call with a number to add those lines for us. To add a helper method that can do that, we can use the @helper directive. I'll call mine icon bars, which looks just like a method declaration in C#. Then I will make it take an integer parameter called count. Inside the helper method, I'll do a for loop that goes from I equal to 0 up to I being less than count and incrementing I on each iteration. And inside the for loop, I'll just add a span tag and a /span tag with the class set to icon bar. Now, back down here where we have the 3 spans, I'll replace that with a call to @icon bars 3. That should output 3 span tags with the icon bar class set on them. Now let's try it out. I'll rerun Chrome one more time and make the window small again so that we can see the mobile version. And you'll notice that there once again is our 3 span tags with the icon bar class. These were generated for us server-side by our inline HTML helper method. If we change this number here from a 3 to a 2 and reload the page, you can see it is actually working to only generate 2 bars. There is another way to create HTML helper methods, and that is to use C#'s built-in extension method syntax for extending the HTML helper class. Let's look at a simple example of doing this with a custom copyright message helper. It will write the footer with the correct copyright message, including the current year, replacing the contents of line 45 here on the layout.cshtml. I'll start by creating a new folder called extensions. This will hold all extension methods that I'm going to create. Let's create a new class in this folder called HTML helper extensions. We'll change the namespace here to system.web.mvc to match the namespace that the HTML helper class itself comes from. Let's also make the class static so that it can define extension methods. And next we'll add a static extension method that returns a string called copyright. Its only parameter will be an HTML helper, and I'll preface that with the this keyword, which is what indicates to the compiler this method is an extension method on the HTML helper class. Now I'll copy the copyright code here from the footer, and I'll reformat that slightly to work well as a string, and I'll return that. And now I can replace that code in the footer with a call to html.copyright. And you can see that IntelliSense now finds our new extension method. So it's just that easy to write your own HTML helper methods and to use those in your Razor pages. But now let's test it out. So if we look down at the bottom of the page, you can see that the copyright message is there, but there's two problems with it. The date time is not being replaced, and the copyright message is being HTML encoded. I can fix one of those very easily. And there, now the date year should appear correctly. But to solve the problem of the copyright being encoded, first we need to remember that strings are always going to be HTML encoded by default by MVC5. To change that, let's change the return type from string to HTML string. And we will wrap this string inside of a helper.raw. And that will prevent this string from being HTML encoded by MVC5. So let's retest it. And now if we scroll to the bottom of the page, you can see that our copyright message is being displayed as expected, including the copyright symbol not being HTML encoded. As we've already seen, MVC allows us to share a general page layout between our different views. The shared folder under Views is generally used for this. But let's look a little bit more into how this works. Remember that all Razor views in ASP.NET MVC5 have a layout property that you can set. In our project, we've set the layout globally using the _viewstart.cshtml file in the root of our Views folder. Now, any view below this level will automatically use the _layout.cshtml that's defined in views/shared, unless it's actually overridden on a view-by-view basis. The contents of the layout.cshtml layout view are mostly pretty simple. You can see that other than a few pieces of code that we've added here, such as the icon bars helper, this view is mostly pure HTML. The other few exceptions being on lines 27, 33, and 36, where we're creating links. We're also using some Razor code down here at the bottom to inject the copyright and current year into the footer. Now, I want to draw your attention to one line that's very important here in the layout view. Look at line 42, where we have the render body statement. This is a special method built into MVC5 that tells a layout view where to inject the contents of the specific view that's being displayed. Notice that if we comment out this line and run it, we get a sort of weirdly formatted 500 error. That's because the page can no longer be rendered using our default layout view because it has no render body statement. To unbreak the views, I'll go ahead and comment that back in. Now let's see how we can use a different layout on different views. Imagine our product manager for this e-commerce site tells us that they'd like to have two different page layouts, one with a footer and one without. We'll implement that requirement by making a copy of the current layout page, and we'll name the copy _layout no footer.cshtml. Now let's edit this layout page by removing the horizontal rule and the footer just below it. Now finally we'll go to the index view of the cart controller, and I'll change the layout here to be underscore layout no footer .cshtml. Now when we run the application and go to the cart page, notice there is no footer on this page. But if we go to another page, such as the product page, we still have our footer. We've now successfully created a new shared layout that we can use on different pages in our application. Now let's look at a few other lines of code in this document. The first one I'd like to look at is actually back up at the top. If you notice on lines 14 and 15, we have two HTML helpers called styles and scripts. These are using a technology called bundles that we only looked at briefly so far. The first one, styles, is for CSS style bundles, and the second one, scripts, is for JavaScript code bundles. If we look at the bundleconfig.cs again in the app start folder, notice on line 24 that a bundle is being created at the URL /content/CSS, which includes all three CSS files in the content folder. First font awesome, then bootstrap, and then a file with some site-specific CSS called site.css. Notice on line 14 of the layout that it is using the same URL /content/CSS. At runtime, MVC5 will create style sheet link tags here dynamically pointing to the CSS files that we just configured it to use as the source documents. Looking at the web config file for this project, notice that the compilation debug mode on line 15 is set to true. When debug is enabled like that, MVC5 will actually write a link tag for each source file so it's easier for you to debug your underlying CSS or JavaScript files. In our production environment, we'd of course want to turn this debug setting to false. And then the bundler will actually combine all of those source files into a single minified one for us at runtime. The scripts.render helper works very much the same on line 15, but it's for JavaScript bundles instead of CSS bundles. If I scroll to the bottom of this document, you'll notice we also have a couple of script bundles down at the bottom of the page. One for jQuery and one for Bootstrap. The last thing I'd like to draw your attention to in this layout page is the render section statement on line 51. This is another statement built into Razor pages in MVC5, just like the render body statement. The render section statement allows a content page to render some code into the layout page at a location in the layout page other than where the main content is already being rendered by the render body statement. In this case, on line 51, we're allowing content pages that use this layout to render some content into the end of the document. This one might be ideal for writing some custom JavaScript to the page, but you could also imagine pages each having their own navigation section that they render differently. Notice that the required parameter here is set to false. If that's true, then every content page that uses this layout page must implement this section. But if it's false, it's an optional section. Let's prove to ourselves that this section is working by adding an easily visible message to the end of the home page. So I'll go into the Views under Home and open up the index. And I'll add the section directive, and I'll give it the name scripts to match the defined name in the layout. Then I'll use curly braces to delimit the beginning and end of this section. And inside of here, we'll put two h2 tags with the message hello sections. Now we'll run the project to test it out. And as you might expect, at the bottom of the page, you can see our H2 tag that says Hello Sections. So we know the sections are working. Looking back at the layout, remember that we made the sections non-required or optional, so we don't have to specify a script section. Now let's talk about partial views. Partial views are a useful way to eliminate duplication of code by reusing part of a view multiple places throughout your application. Partial views can be used in layout views, content views, or even in other partial views. Let's go back to the main layout view and move the navigation bar from the layout into a partial view that we can reuse in the layout no footer layout that we created in the previous video. Since a partial view is meant to be shared, we'll create ours in the Shared folder under Views. And I'll pick Add View. I'll check the checkbox to create this as a partial view. That essentially removes the ability to specify a layout page. Since this view is no longer a content view, specifying a layout page wouldn't make much sense. We need to give our partial view a name, which is often prefixed with an underscore to help differentiate it from content views. I'll use underscore navbar. Everything else I will leave the defaults, including the empty template. With the empty view file now created, let's go back to our layout and we'll grab the HTML to the clipboard that we're going to use. So let's copy this navbar div right here. And we'll cut that to the clipboard and paste that into the navbar CS_HTML. Notice on line 5 that the icon bars helper is creating an error for us. That's because the icon bars isn't defined here, it's actually defined over in the layout. So I'll go grab that as well and cut that to the clipboard. And go back to the navbar and paste my helper method in there at the top. And notice now that the error goes away. Let's go back to the layout, and in the position where the navbar used to be, I will add an @html.partial. This tells MVC5 that we'd like to display a razor partial view right here. As a parameter, we'll pass a path to the razor view that we'd like to use, which is views shared underscore navbar.cshtml, which is the path to our partial view. Now MVC5 will render this partial view right here inline in the layout page where it used to be defined hard-coded. Let's see what it would look like to share this partial view elsewhere. I'll go ahead and copy this partial view command, and we'll find the navbar where it's defined in the no footer layout, and I'll paste that in instead. Now, this no footer layout should also use the same navbar that we are using in the main layout. Let's run it and see how it works. Here I am on the home page, and we can still see the navbar. If I go to the cart page, which has a different layout, you can see no footer here at the bottom, you can see that we also have the navbar displayed on this page. We've now used partial views to successfully reuse view code in multiple views in our application. Because the @ symbol has a special meaning in Razor syntax, we need a way to escape it so that we can use the @ sign for other purposes like email addresses or Twitter handles. The Razor parser is often smart enough to catch things like email addresses, but Twitter handles starting with an @ sign look exactly like Razor code. Imagine, for example, that we wanted to put the H+Sport Twitter handle in the footer of the page. We might do it like this, by putting in a pipe followed by an anchor tag with an href that points to https://twitter.com/h+sport. And we'd probably want to set the target to blank so that it opens in a new tab or window. And inside the contents, we want to put h+sport. And you can already see that the Razor parser is having trouble with this. In fact, it's having so much trouble that if we launch this in the browser, you can see that the page is completely broken. The solution is quite simple in Razor. We just use 2 @ symbols to escape it. And if we save that change and reload the page, you can see now that the Twitter handle is working perfectly correctly in the footer as we intended it. As we discussed earlier in this course, ASP.NET MVC 5 was designed to follow the MVC, or Model View Controller pattern. But the MVC pattern is just one of a family of related patterns which includes, among others, MVC, MVP, which stands for Model View Presenter, and MVVM, which stands for Model View View Model. Of course, each of these different patterns has its own advantages and disadvantages. Each pattern is also concerned about different things like which element is directing things or which elements know about other elements. In this course, we're not going to get into any more detail comparing these patterns, but I did want to mention them so that you were aware that what I'm about to show you might fit more closely into the MVVM pattern, or at least that's what some might argue. So far, we've talked about the model class in MVC as being your application's data or state. Because of this way of describing it, a lot of people might think that the entities from their database should be used directly as their MVC model object. In the MVC pattern, there's nothing wrong with this approach, and it can work perfectly well in some situations. However, I find it doesn't adequately model the complex relationship that exists between a typical database entity and the data that you're trying to display on a view. Because of that, I recommend a slightly different approach that involves 2 types of data object, data entities and data models, or just entities and models for short. Following this pattern, we can load an entity or a bunch of entities directly from our database, and then use a model class to manipulate or map those entities into a form that's more directly useful to a view. In that sense, we're doing something very similar to a view model in the MVVM pattern. Throughout the rest of this chapter, we'll be looking at examples of using Entity Framework entities as our MVC model, and this will be done primarily for simplicity. In a full-scale application, you might consider using your MVC model class more like a view model to manipulate your data entities into a shape that is best used by your views. Now let's look at auto-generating your model classes using Entity Framework 6. But before we get into that, I want to point out that these are the first demos that we're going to use with the SQL Server database backup. If you haven't already restored your database to your local DB development database, you could do that anytime now. The database backup file is in the exercise files for this video under the data folder, and it's called database.bak. If you haven't done that before, you can use the instructions at this link on your screen to restore the database using SQL Server Management Studio. If you're interested in learning more about Entity Framework 6, check out the course Learning Entity Framework 6.1.3 in this library for a great introduction. Now that we have our database set up, let's take a moment to review the Entity Framework code that I've added for you in the Begin folder in the exercise files for this video. Notice first that we have a data folder, and inside that folder we have a DB context called h+sport DB context, and an entity folder with data entity classes defined in it. If we look at the cart class, you can see it's just a plain old CLR object, or POCO, and it's not inheriting from any special base class or anything like that. Each of the fields from the cart table have a property here, and any relationship to another table is represented with a navigation property. In this case, the cart products collection and the customer property. If you look through all of these other entity classes that I generated for you, they're all very similar, each with properties for their database fields and navigation properties for their relationships. The next thing we should look at is the DB context class called h+sport DB context. This is a very typical DB context class for Entity Framework. Each database table is represented with a DB set collection property, and the onModelCreating includes any special database to entity mapping logic. Notice that the constructor is looking for a data connection named H plus sport. Let's go look at where that's defined. Here I am at the bottom of the web config file under the connection string section. You'll see I've created a connection string with the name H plus sport, which is exactly what the DB context class was looking for. It's connecting to the local SQL Express local DB instance and looking for a database named H plus sport. It's also using integrated security, meaning it will log in with my local development user. If your database setup is any different from this, you might want to change your connection string here to match it. Now that we've reviewed what I added for you, let's add a new view to view a customer's address record. We'll actually start by making some changes to the index view for the account controller. First, let's use the @model directive, and we'll specify the type that we're going to use for our model here to Razor, which will be h+.ecommerce.data, entities, and finally customer. Now let's go to the end here and add a paragraph tag, and we'll add to this paragraph model.address1, followed by model.address2, and then on one line, model.city, comma, model.state, space, model.zipcode. And we'll put a line break at the end of each of these lines. And then finally, let's make sure that the address2 only displays if it's not null or empty. We'll do that something like this. If not string.is null or white space, model.address2. Now, when we bind a customer entity as the model of this view, all of these properties will be displayed. To do that, let's write a little bit of C# code in our account controller. First, we need to create an instance of our database context, which is called H+ Sport DB context. Let's do that as a variable called context. And let's do it inside of a using block. I'll also add a variable here, which is of type customer, called customer, since that's what we're going to be trying to look up, and I'll default it to null. Next, we'll try to find the current user, which we're going to do by querying our users collection with Entity Framework based on the identity of the currently logged in user. Something like this. Var user equals context users, first or default user, such that user.email address equals currently logged in user's identity name. And if that user is not null, then let's try and grab the customer by going customer equals context.customers, first or default, customer, such that the customer's customer ID equals our user's customer ID. And then if we found that, let's go ahead and run the view and pass it that customer. And let's try that out. If we try and navigate to the account view, it'll ask me to log in. If I use a valid user from the users table in the database, like jtower at samplecustomer1.com, and then I can use any password right now since we're not validating that. This should log me in as a valid user and retrieve a customer record on the account page. And you can see that our view is loading with that customer record for this user and displaying that customer address from the record. So we've seen how we can use Entity Framework classes as our model, and just how easy it can be to do. Consistent and easy data validation is one of the most important things a framework can provide. To accomplish this in ASP.NET MVC, we'll use a combination of something called ModelState and the system.componentModel.dataAnnotations namespace. Let's look at the data annotations namespace first. This namespace has been around since the very early days of .NET, and it's one of the things about .NET that's changed very little over the years. It turns out frameworks come and go, but data validation stays roughly the same. We'll use the login model from our login view to try out data annotations. Let's add one of the most common data annotation attributes here, which is called the required attribute. Once I add it, I'll need to import the namespace. And now I can use other attributes from that namespace, such as the email address. This requires that a string property be formatted as a valid email address. Or I could do the min length and specify a number. This requires a string property to have at least 8 characters. Each of these attributes includes a built-in error message it will generate for invalid values if I don't provide another one. If you'd like to provide your own error message, you can simply provide the error message parameter for any of these validation attributes. For example, on the email address, I can specify error message equals, and then I could use a nice error message like usernames must be valid email addresses. Or on the max length, I could provide an error message such as this password is too short. There are several built-in attributes that will cover most validation situations, but if not, you can always create a custom validation attribute yourself. The built-in ones include the compare attribute for comparing 2 different properties, such as password or confirm password, data type for checking that a value parses as a specific type, like a number or a date, for example, min and max and string length, all for checking the number of characters in a string, required to say that a value is required, range for numbers within a specific numeric range, and regular expressions for almost any other situation if you know how to write those. With these attributes specified on our model class now, we're all set to use the other half of validation in ASP.NET MVC 5, which is called ModelState. Let's look at that now. Now that we've added the data annotation attributes to our login model, let's actually ask the controller class to validate that model when it's submitted. Here in the login controller, let's add a line before any other processing happens. If, and then we'll say not, and then this is where we access the ModelState property of the controller and check its isValid property. Just by accessing that isValid property, that will trigger MVC 5 to look at all of the parameter types on this action method and any data annotation attributes, and to run those validation attributes. If any of those attributes are invalid, the isValid property will return false. So if it's not valid, we want to return the same login view again. And we'll pass the original request back to the view. Something that happens behind the scenes, though, is that MVC 5 also sends the ModelState property to the view. Now, with just a couple of more changes to the view, we can actually access that ModelState and display any error messages to the user. Back in the view, we can use the HTML helper to create a validation message for each of the fields on this form, username and password. Here in the login view, we'll go right below the text box for HTML helper for the username, and we'll add a new HTML.validation message for helper, and we'll have it look up the model's username property. This will create some validation message placeholder HTML for us, and it will check the ModelState property of the model and see if the username field has any validation errors to display. Let's do the same thing for the password field. And now if we run this in Chrome, watch what happens when I submit some invalid data for this form. We can see an error message display below each invalid field with a custom error message that we specified. The summary at the top of the page is still displaying the hard-coded message saying invalid login attempt. Let's go ahead and update that to use the ModelState information as well. Back in the login view, we'll replace our hard-coded message with the following HTML helper: HTML.validation summary. This will create a summary of all of the validation issues with this entire form and display it here. Now we can try submitting some invalid data again. And notice this time, in addition to the errors appearing below each field, there's also a bulleted summary list displayed at the top of the form. We've now put all the pieces together for data validation in ASP.NET MVC 5. Data annotations, ModelState, and the HTML validation helpers. As I've mentioned, there are many built-in validation attributes available in ASP.NET MVC 5, including a regular expression one that serves as a good catch-all. However, if the validation rule that you need isn't available, you can still always write your own custom rule. Let's imagine we wanted to validate our users' passwords to make sure that they weren't using one of the 10 most commonly used ones. And we wanted to reuse that validation logic both in the login and on other screens, like maybe in the future if we created a password change screen. I've gotten you started with a new class in the validation folder. You can find this in the project in the begin folder of the exercise files for this video. First, notice on line 9 that this class inherits from the validation attribute class defined in system.componentModel.dataAnnotations. This is the main thing that you have to do to create a custom validation attribute. Also notice that my class name common passwords attribute ends with the word attribute. This is a convention for all attribute classes in .NET code. When we reference this class as an attribute in our code, we can either include or omit that word attribute. Both will work. Next, notice on line 12 that I've created a string array of the 10 most commonly used passwords at the time of this recording. As a side note, please don't use any of these passwords in real life. They are literally the first 10 passwords that any hacking attempt will try. Next, notice on line 11 that I've defined a field to hold an error message if we want to override the default one. This is being set on line 27 in the constructor, which is where we'll pass the error message into the attribute when we're setting it up. To make this work, let's override the isValid method from the base class. We'll go ahead and get rid of the implementation from the base class. And the first thing we need to do is make sure that the value isn't null. So if it's null, let's just go ahead and return false, saying this is not valid. And then next we'll check to see if the bad passwords array contains the value. So if the bad passwords contains the value when converted to a string, and then we'll reverse that with a not and return that result. In other words, if we find the value in the bad passwords array, the value is not valid. And that's all we have to do to get that to work. But I'd also like to add a default error message and the ability to override it. So let's also override the format error message. And we'll return either error message if it's not null, or if it is null, we'll return name is too common, where name is the name of the property. Now let's actually use this custom validation attribute in the login form. Eventually, if we added a change password page, we could use the same attribute in the model for that page as well. In front of the password property here, I'm going to add a common passwords attribute, and I'll import that namespace. I'll also specify a custom error message of this password is too common. This will validate the property using our new attribute, plus it will use this custom error message instead of the default one that we built into the attribute. All right, time to test it. I'll go to the login form, and I'll enter a valid email, and I'll enter one of the passwords from our list, 1, 2, 3, 4, 5, 6, 7, 8. Notice that we see our custom validation message inline in the form and in the validation summary at the top. Now we know how to validate HTML5 forms with the built-in validation attributes, which cover most situations, and how to make use of our own custom attributes when we need to do that instead. Microsoft has made unit testing your ASP.NET MVC5 projects very easy by providing a unit test project type in Visual Studio. In the Begin project in the exercise files for this video, I've added a unit test project to the solution for you called hplus.ecommerce.tests. It has one test class in it right now called sampletest.cs. If we look inside the class, you can see that it has a couple of test methods. I've broken each one down into 3 major steps of the AAA pattern for unit testing, which stands for arrange, act, and assert. In arrange, we get the test set up or arranged. In act, we take the action to execute the code that we're trying to test. Finally, in assert, we assert things that should be true about the results if the code is working correctly. Notice that the class is marked with a test class attribute on line 12, and that each of the test methods is marked with a test method attribute, like on line 15 and 27. This tells MS Test and Visual Studio which classes and methods to run when they are running unit tests. In Get Login Index on line 16, I've set up the arrange and act steps for you. First, I'm creating an instance of the login controller, and second, I'm executing its index action method and casting the result as a view result. Let's test this now by asserting that the view name is correct. Since the method is called index and so is the razor view, this method could specify no view name and it would automatically use the name of the action method, index. It could also explicitly specify the name index, so let's test for both of these valid cases. I'll put in the code assert.isTrue, result.viewName equals quote quote, or result.viewName equals index. This will ensure that the view name is either blank, which will default to the action name index, or that it was explicitly set to index. If neither of those is true, someone must have unintentionally changed the view for this action method, and this test should fail. I'll add this same line of code to the next test method, which is testing the product controller's index action. Let's test these 2 tests in the Test Explorer in Visual Studio. If I click the Run All, it will run all the tests, and you can see not only the times that it took to run each test, but you can also see that they all passed. Now you've seen a very easy way to test all of the action methods to make sure that they're returning the correct view. Next, let's look at testing the data model loaded by the controller for a view. If you want to test something more complex about the logic of a view, you may need to access its model, either through the view data, view bag, or its strongly typed model. Let's test the data being pulled back from our product detail view. If we peek back at the product detail endpoint, note that it's using the product property of the view bag on line 17. It's not hard to imagine this data being loaded from the database using the product name or product ID, But in this example right now, we're actually hard coding that value. Let's go back to the sample test class in our test project. We'll add a new test method called getProductDetail. I can copy the arrange and act sections from above, but I'll change the assert. And I'll change the index to detail, which is the endpoint that we're trying to test. And if you recall, the detail action method takes a product name. So I'll specify women's winter jacket. Finally, let's assert a property of the view bag that we know will be true if the women's winter jacket is what's loaded into the product view page. I'm going to use the assert are equal assertion because this time I'll be comparing an expected value to an actual value. For the expected value, I'll specify women's winter jacket. And for the actual value, let's specify an object called product. This doesn't exist yet, but we'll create it in just a second. To create the product, let's grab that from the result.viewBag.product property. And then we'll change the value we're comparing from the entire product object to the product's name. And furthermore, we should cast this as the product type that we know it is. Now back in the Test Explorer, let's run this new test by right-clicking on it and running just the selected test. As you can see, Visual Studio will compile the project and then run that test, which in this case passes because the expected value matched the actual value of the product name. This is a great way to make sure that as I maintain this application and add features to it, I'm not getting any regression bugs.